iLogic, very much so, can be used for developing small tasks. So different things that you want to do on a regular basis. Okay. So small tasks. You don't have to be a programmer in order to use iLogic. You don't have to, you don't have to have, some sort of computer science degree. However, the real important thing is you do have to understand how Inventor works. I've said this before in a lot of my other webinars is iLogic doesn't change how Inventor works. It changes how you work Inventor. Okay. So if you don't understand that in order to create an extrusion, I need to create a sketch first. And inside of that sketch, I need to have sketch entities. Well, then you might have a challenge when it comes to writing some sort of logic to do something with an extrusion or in a sketch that might be associated to an extrusion. So it's very important to understand how Inventor works before you start messing with iLogic. So if you want to create a rule, quite simply, if you right click, say add rule, you're going to give it a name, you're going to hit OK, and it's going to take you into the rule editor. Okay. On the left-hand side, we have a series of snippets, and this is pre-installed code, if you will, little bits of code, we call them snippets, to help you and guide you along the way of if you want to do something that might affect a model or in an assembly or something else. So, and it's broken down into categories as to if I want to do something with specific parameters, I can, or pardon me, if I want to do something with a feature like turn it on or off, if a condition exists, I might want to turn off different features in a part. But if a different condition exists, maybe I want to turn them on. Okay. So I could go through this whole list, but the important thing here is to understand that if you're new to iLogic, take a look at these snippets. But also keep in mind that this is just to get you started. Okay, this isn't everything that iLogic can do. This is just some of the basic things to get you a little bit more familiar with iLogic and the Inventor API, which is the important aspect of what iLogic is all about. But we'll get to that. Up here on the top, it exposes, iLogic Rule Editor exposes any parameters that I might have involved, any features I might have involved, any parameter names or any feature names over here. And then this is our Rule Editor pane down here, where we can do different things like indent or comment or do different conditional expressions if we'd like, as well as understanding different keywords or operators that we might want to use in order to develop our code. And I'll get into some of those examples here in a little bit as well. So I'm not going to save this rule. I'm going to open up this rule that I have existing inside of my model in a moment here, just to understand what small tasks are in this regard. So I'm in an engineering department. I'm not using iLogic at all. I want to start using it. One of the best ways to start that process is to start understanding small tasks. So an example of a small task is what I have in this rule. This is a material rule that I created. And essentially, if you're familiar with Inventor and you have templates and you haven't done anything with your templates, you're going to have a standard IPT. Now, when you're developing information inside of Inventor, perhaps I need to create a product. Maybe it's a steel shape. Maybe it's a bracket, if you will. Okay. If I create that bracket, I'm going to define my geometry. I'm going to throw some holes in it, perhaps. And once I'm done with it, I'm going to save it and I'm going to use it. But one of the things about working with the standard templates is that if I want to do something, I want to make sure that it's accurate. So I want to fill out all my I properties. I want to make sure that my part number and my stock number and my description is there. But I also want to make sure that my material is accurate. So that way, if I'm doing any analysis or if I need to do any calculations in terms of weight or volume, that I'm doing that appropriately by setting the material. Okay. So in Inventor, if you don't set the material, it always uses this generic material. So what I did is I wrote a simple little rule that goes through the process of if the material is generic, whenever I save this model, I'm going to get a message box, and then I'm going to get an opportunity to change the material to make sure it's accurate. So this is a rule that you would incorporate into your template. So as your users start developing components associated to an assembly, perhaps, that we're avoiding using the generic material type. And how it works is if I run this rule, it's just going to do a quick check. It's going to say, hey, the generic is not a valid material. If I hit OK to proceed, it automatically opens my iProperties, takes me directly to the physical tab, where then I have the opportunity to change my material, so that way I'm developing accurate models. Okay, so a small little task, something that a lot of companies, you know, they need to enforce that fact that we need to develop accurate models. But here's a tool now to give to your users to make that a little bit easier, to remind them, hey, this is part of your responsibility. How about creating some sort of automation or logic to make those processes a little bit quicker? Another example of a small task model that I developed was something like this pipe. Okay, so I used to work in industries where, you know, we're cutting metal, we're welding things together, we're bolting things together. You know, creating steel shapes is a very common activity. So a lot of the time in design, what we'll have is we'll have templates where we can go, or we'll reuse existing information. Excuse me. Perhaps I used a pipe in some other design. I happen to remember that design. I go to the pipe, I save copy as, then I tweak the geometry to get to the right size. Everybody's familiar with that process, but that may not be the most efficient way of doing it. So what I did is I created this model that has a couple little rules in it that allow me to define what kind of pipe I'm creating. So in the terms of this example, I created a form that leveraged different parameters that are associated to this model. So as opposed to going to my parameter dialog box here and start affecting my parameter values, I created a little form that connects to those parameters in order for my end users to quickly input information to drive a configuration. So maybe my diameter is a 5-inch diameter, and now my pipe changes to 5-inch. Oh, in this case, I have to set this to round tube in order to do that. So now I have 5-inch round tube. What's my wall thickness? Or if it's a pipe and I want to use a particular schedule, I can change my schedule 80 maybe, and my wall thickness changes. So all these parameters are doing is they're driving the rules that I created, and then the rules are manipulating the geometry. So that way we're adhering to some sort of design standard. If it's a pipe and I use a particular schedule, I can define a material, define a diameter, and a lot of other things are automatically going to update. So this is a small task type of rule or series of rules that allow me to quickly generate a pipe of the appropriate size that I need for my design, as opposed to going to a sketch or going to a feature and manipulating geometry. I plug in engineering specific information, and then I output the accurate model. So it assists with my process. What do these rules look like? Very, very simple. Excuse me. If I want to do something with material, all I'm doing is I'm saying I have a multi-value list property and I want it to equal the iProperties material. And then I'm turning around and I'm setting that to a parameter. So that way, as I change the parameter, it's going to drive this. And then what it's going to do is, based upon that material, I'm going to do some sort of calculation to update a custom iProperty called RWT, which stands for rough weight. So as I change my model configuration, if I want this to be maybe a 6-inch pipe, oh, that's not going to work. Let me change this to round tube. I want this to be a 6-inch round tube. If I hit done here and I go to my iProperties, I have a custom iProperty called RWT. It's giving me the rough weight of this component. If I go and make some other change here, maybe I want this back to be pipe of a different size, and then I go back to my iProperties, my RWT is now of a different value. So it's automatically updating properties as I make parameter changes to ensure accuracy and consistency. So very, very simple rules in order to do something very, very common that we have to do on a regular basis.